welcome back, code friends and code family, to Cajun Coding. This is Saint Raz, and we are continuing on in our mission to learn Python 3, assisted by the SoloLearn application and the MemuPlay emulator, allowing me to treat, for the purposes of these lessons, my laptop computer as an Android smartphone. I don't know whether SoloLearn is available via Apple. It's a very well established application on Android. Given the size of the community and the content, I would be super surprised if it was not available on Apple. So pretty confidence there if you have an iPhone. But in any case, we are going to the section Exceptions and Files. What do we have? No, we finished control structure. Yeah, functions and modules was the last one. So we're moving on to exceptions. And as you've already seen, exceptions, or rather it says you have already seen exceptions in previous code. They occur when something goes wrong due to incorrect code or input. When an exception occurs, the program immediately stops. The following code produces the zero division error exception by trying to divide by 0. And you'll see it's the name of that exception is the zero division error. And then explains further division by 0, which doesn't sound like much of a more detailed explanation, but kind of is what it is. How much can you say about that without getting into the mathematical reasons why you can't divide by 0, which I'm not going to get into right now. But what is an exception? Well, we've covered functions and variables, and an exception is definitely not a function or a variable. It's an event that occurs due to incorrect code or input. Test taking tip, I don't know if they've corrected for this in the past dozen years or so, but when I was taking standardized tests in school and such, and also in university as well, the longest element, the longest option in a multiple choice exam tends to be overrepresented as being correct. So may not always be the longest, but we've got 3 options here. The chance that the longest response is correct is probably better than the 33% that we would expect out of 3 options. If you were completely lost and don't know what to do, I would go with that longer option. Certainly hope that you've had preparation and opportunity to not be completely lost when you're taking the exam, but if all else fails, you just got to go with the numbers. Exceptions. Different exceptions are raised for different reasons. Common exceptions: import error and import fails. Index error: a list is indexed with an out of range number. Say you check for you want an element at index, but the index that you pass in is -1, or say the index is 10 but there's only 9 items in the list. Well, then you would get the index error. Name error: an unknown variable is used. Something like that is very often a typo, or maybe you change the name, like you wanted to call it cat, and then you say, well, no, dog's a better variable name, and then you forget about that, and later you access variable cat. Well, you use dog for the name instead of cat, so that would be a name error. Syntax error: the code can't be parsed properly. Type error: a function is called on a value of an inappropriate type. So let's say you call a function, it needs an integer, and you pass in a string for some reason. Well, that would be a type error. Value error: a function is called on a value of the correct type but with an inappropriate value. Say the index error, where it needs an integer. Well, the indices in a list are integers, but they're all positive integers. The very first item is going to be the address is going to be 0. Next item is going to be 1, and so forth. Well, if you call -1, well, -1 is an integer, so it's the correct data type, but that would be a value error it's an inappropriate value. Now, in that particular case, it would be an index error, but you could see an index error as being a type of value error. In another situation, I'm trying to think of an example right now, but in any case, it would be the correct data type, but it's a inappropriate value for whatever reason. There's several other built-in exceptions, and they didn't list zero division error there. Zero division error, OS error. I don't know what an OS error is, but I assume that it's probably operating system error. So it's an error that would be thrown if the operating system, say it's an Apple operating system or Windows, or if you're using Linux, for some reason it's not the Python program, it's the operating system that is causing an error, maybe some incompatibility with certain features or something like that. Third-party libraries also often define their own exceptions, and you can basically customize exceptions if you don't want a certain certain type of input, or you want to flag something as being invalid for whatever reason that's not already defined in the Python language. Which exception is raised by this code print. Let's see, 7 plus 4. Now 7 is a string and 4 is an integer. And that would be a type error, because what you're trying to do is you've got a string and an integer. If they were both integers, this would be a plus. They would just be added together. If they were both strings, that symbol is actually the concatenate symbol, and we're just going to print the 7 and then print the 4, and we'll have 7, 4, which is also a string. Now, if one's a string and one's an integer, first of all, we don't know what this operator means, because it's not the concatenate operator, because they're not both strings. It's not the integer operator, the sum operator, the addition operator, because they're not both integers. Plus, it's kind of ambiguous as to what you actually want to accomplish. Do you want to print out 7, 4? Do you want to add the integer 7, 4 and display 11? So because of all that ambiguity, it's going to throw a type error, because you've got two different data types, and the interpreter really doesn't know what you want to do with it. Exception handling. To handle exceptions in a call code, when an exception occurs, you can use a try except statement. The try block contains code that might throw an exception. If that exception occurs, then the code in the try block stops being executed and the code in the except block is run. If no errors occurs, the code in the except block doesn't run. This is kind of like in, well, I hesitate to say that now. It's kind of like an if-else structure, in that it has two different possibilities for what code block is going to be run. Other than that, it's not real similar to if-else, but it does have that commonality. So we've got try. Try is always going to attempt running, but it may throw an error. If it throws an exception, then it may print out this, it may execute the code block here. Now, you see here it says except and then zero division error. If it throws another exception for whatever reason, it's not going to execute this code block. It has to be the exception that is specified in after the except keyword there. So actually there's three possibilities. Either try operates without error. So I actually did have to pause there for a second. Actually, it would be the try runs without exception, without problem. If an exception is thrown, the except conditional here checks to see if the error is of the type specified. If it is, then the code block here runs. If there's another exception, the try block will terminate with the exception. The exception does not match the one specified, then the program would terminate with that exception type, whatever that was. So me see, except statement. Oh, and of course this is basically telling me exactly what kind of exception to handle, which is what I just explained. What is the output of this code? Try. Variable is assigned a value of 10. Print 10 divided by 2, except 0 division error, print error, and then print finished. 10 divided by 2 is 5. Now it's division, so it's going to be 5.0. An exception is not thrown, so it does not print error. This print statement, as you can see with the indentation here, is in the main thread of the program. So it's not off in a branch, like it's not inside the except division, 0 division error. So this is going to print regardless of what else happens, whether there's an exception or not. So it's 5.0, but it's going to print finished as well. So 5.0 finished. A try statement can have multiple different except blocks to handle different exceptions. Multiple exceptions can also be put into a single except block using parentheses to have the except block handle all of them. So let me see, except 0 division error, print divide by 0, except value error, inside parentheses, value error, comma, type error. So if either one of those occurs, you get the statement error occurred via the print keyword, which is great because that's no more information than you would get if it just had no exception block. But that's not the point. We're learning how to do those, do these. So if you are if you're making a custom exception block, you would want to have in reality more information than you would get from the interpreter alone anyway. So tap, try it yourself, play around with the code. We're not going to do that right now. We'll have plenty of time to play around with plenty of code. What is the output of this code? Try, meaning is going to be assigned value of 42. Print, meaning, divide by 0, print the meaning of life. Exception, except value error or type error, it's going to print. I shouldn't say return. That's a special word. It means something else. It's going to print or display value error or type error occurred, except 0 division error is going to print divided by 0. As you can see here, we are dividing by 0, so it's going to display divided by 0. And the meaning of life is 42. That's actually not a reference to Monty Python. That's actually a reference to the series of books Hitchhiker's Guide to the Galaxy by Douglas Adams. Also a British gentleman, as is Monty Python is a British comedy troupe. But highly recommend Monty Python and definitely Douglas Adams. Very great humor. Exception handling. An except statement without any exception specified will catch all errors. These should be used sparingly, as they can catch unexpected errors and hide programming mistakes. Basically what we're doing here is except. We don't have any specifics here, so we just display an error occurred anytime any exception is thrown. Well, instead of getting a message, whatever the default message from the interpreter relating to that error, which would give us some information about the nature of the error, instead, anytime any error occurs, we just print an error occurred, which is going to mask the symptoms of the problem. So you would really want to be careful with these. It's very hard to speak in absolutes, so I won't say you will never use it or you should never use it, but you shouldn't be using them a lot. And we know only Siths deal in absolutes. Okay, so exception handling particularly useful when dealing with user input, because we know those users, the operator of the program that's finished. My dad was a process plant maintenance guy for years and years, and the guys that operated the chemical factories and petroleum refineries and such. The ones who operated those facilities were called operators. And my dad always said an operator could break an anvil with a banana peel. Said in love, of course. Okay, fill in the blanks to handle all possible exceptions. So what are we going to do? We're going to try to do this right here. And if that doesn't work, oops, except actually has an X and a C. Don't forget the colon there. I'm not going to specify any specific type of exception, just any exception. I wouldn't know if this was handling all of them. Technically this is exception handling because we're using the except keyword and we have a code of block. I wouldn't say it's handling it very well, but it's just demonstrating it for the lesson. And finally, we're getting to the finally keyword. To ensure some code runs, no matter what errors occur, you can use a finally statement. The finally statement is placed at the bottom of a try except statement. Code within a finally statement always runs after exception of the code in the try and possibly in the except blocks. So we're going to try to print hello, 1 divided by 0, and we know how that's going to turn out, except 0 division error, which of course we're going to get because we're trying to divide by 0, and we're going to print divided by 0. Either try is going to work or except is going to work. Either way, finally, we're going to print this code will run no matter what, which kind of what it says on the can, that code is going to run no matter what. Now it says possibly in the except blocks. Actually, this code might not run no matter what, and I actually don't know this, so let's figure it out together. What happens if we throw an exception, but it's not a 0 division error? If it's not a 0 division error, then is this code going to run? Well, if we run this, we'll see, hello, we divided by 0, this code will run no matter what. Let me see, hello, let's change the error type. What's type error? That's a different exception. So let me see, type error. Okay, so we're going to divide by 0. It throws an exception, so we check the except, but divide by 0 is not the exception we're looking for. So this code divided by 0 is not going to run. The question, finally, is this code going to run no matter what? So let's see what happens. Hey, look at that. So it says hello. This code will run no matter what. Now we did have an error. It threw an error. Playground. See, playground file. Line 3 module. Okay. I think that this error came back because we're not using a Python interpreter exactly like you usually would have one, because we're actually connecting with the remote server that SoloLearn uses. So I think that this would probably behave differently in using a native Python interpreter. Excuse me, a local Python interpreter. But that's really not the question we were looking for. We weren't looking for what kind of error we would get. We just wanted to know whether the finally would print this code this code will run no matter what. We wanted to know if this code would run even if we got an error other than the one that we had handled, and we can see that it actually does. So good to know. We're learning together. We don't need to save that. Okay. What is the output of this code? Try, print 1, except, print 2, and finally print 3. Okay, so we're going to try to print 1. Well, there's no errors or anything in this, so we're not throwing an exception, so we're not going to run the code block under the exception handling section. Finally, we're going to print 3 whether we have an exception or if the try executes. So we're going to print 1, 3. Just like that. Code in a finally statement even runs if an uncaught exception occurs in one of the preceding blocks. So it looks like the little detour we made earlier is something that the designers of the course actually thought of and they decided that they should address. We've kind of already done that, so I'm going to kind of skip over this. We already went into that. And sometimes you'll see potential problems or questions, and you can do a little experiment and find out something before it's addressed in the course. That's awesome. That means you're doing well, and you're kind of keeping your eyes open. Don't feel bad if that doesn't take place, because a well-designed course, a good mentor is going to introduce you to those concepts anyway. And sometimes you might not really want to get deep into the weeds with your experiments and investigation until you've finished a course and something hasn't been addressed. If that's the philosophy you're going to take, I would say write those things down, keep a little record somewhere, so that if those questions aren't answered in the context of the course, or your mentor doesn't have information for you, then you can investigate it. So don't let it fall by the wayside. But drag and drop from the options below to create a try except finally block. Wow, I can't believe this is a question. Okay, it's going to be a try except finally block. Talk about a softball. Okay. Raising exceptions, not expectations, exceptions. You should raise your expectations too, though. You can raise exceptions by using the raise statement. Print 1, raise value error. Print 2. And this is basically just displaying value error there. I'm assuming that we're going to use raise exceptions using some conditionals and actual, real life programs. You're not just going to value raise an exception for no reason. It says you need to specify the type of exception raised. That's what value error is. If you says raise objection, well, that might work in a courtroom. I don't think it's going to work with the Python interpreter. So this value is going to have to be something that is established as an exception type. Now it might be you could create a custom exception type called objection, but unless you have, or unless to my surprise there actually is a objection type of exception, that's not going to work. So which errors occur during the execution of this code? Try print 1 divided by 0, our favorite logical error. Except 0 division error. Raise value error. Wow, okay. That's crazy, but I'm going to say it's going to be value error. Which, oh, really? 0 division error. I think it's going to be both, is it? See, 0 division error, value error. Is it going to be both? It is going to be both. It actually, this part here actually causes a 0 division error. Okay, except when we see 0 division error, we instruct the interpreter to raise the value error. So it actually raises both. My logic in the earlier answer was that because it threw a 0 division error and you're instructing it to raise the value error, that would overwrite the 0 division error and it would just throw the value error. But apparently I was incorrect about that. So it actually throws both of them. Raising exceptions. Exceptions can be raised with arguments that give detail about them. For example, name 123 raise, name error invalid name. So it's going to throw the error type, and I think a name error, that might be a custom one that they made for this example. I'm not sure actually, but it's going to throw the error. It's going to display the type of error, and then you can insert additional information about the error there. And let me see. Fill in the blanks to raise a value error exception if the input is negative. If float num, well, negative means that it's less than. Then we're going to throw raise value error negative. As you might have noticed, the generation of an error is sometimes called throwing an exception or throwing an error. It's something that's used a lot. I don't think that the keyword, I haven't encountered the keyword throw in Python in this course. Some other languages actually use the word throw as a reserved keyword in the language, but do be familiar with that terminology though, because you're going to be hearing it from other devs. In except blocks, the raise statement can be used without arguments to re-raise whatever exception occurred. For example, try num 5 divided by 0, except print an error occurred, raise, just raise, with nothing else specified. It will display the error of the type that was thrown. Can you use a raise statement outside the except block? Actually, I believe you can. And we showed that earlier where we had a brief section of code where we literally just raised an error out of nowhere. There was no try or exception block. Assertions. An assertion is a sanity check that you can turn on or turn off when you have finished testing the program. An expression is tested, and if the result comes up false, an exception is raised. Assertions are carried out through the use of the assert statement. And here we see assert 2 plus 2 equals 4. Well, 2 plus 2 is equal to 4. And then we have assert 1 plus 1 equals 3. Well, obviously 1 plus 1 is not equal to 3, and it throws an error. The exception name, it shows an assertion error. Programmers often place assertions at the start of a function to check for valid input, and after a function call to check for valid output. What is the highest number printed by this code? Well, it's going to print 0. It's going to assert H is not equal to W. It's comparing strings. Anything different about those strings, including case and white space like spaces, is going to mean that they are not equal. H is obviously not equal to W, so it's going to print 1. So we got 0, 1, assert false. Well, an assertion that is not true is going to throw the assertion error. Well, we're not even making an expression here. We're just stating false. So assert false is going to throw that error. So it would be, the highest number would be 1. It would be 0 and then 1. Highest number would be 1, like that. The assert can take a second argument that is passed to the assertion error, raised if the assertion fails. So temp -10, assert temp greater than equal to 0. Well, we established temp was -10, so it is not greater than equal to 0. This is the second argument, so it's going to say colder than absolute 0. Apparently they're using Kelvin if they're saying absolute 0, which there is nothing colder than absolute 0 Kelvin. But thermodynamic quibbles aside, this is a good little lesson to know. Assertion error, colder than absolute 0. I see. Assertion error exceptions can be caught and handled like any other exception using the try except statement, but not if handled. This type of exception will terminate the program. And here we have an example. And fill in the blanks to define a function that takes one argument. Assert the argument to be positive. Okay, so let me see. So we're going to, no, do I not have focus? Here we go. Okay, I didn't have focus. There we go. Def for defining the function. Assert x is greater than 0, and then error print x. Is that going to work? Yeah, that's it. It says, oh, assert the argument to be positive. Well, we don't really know what x is, so I wasn't sure if this is going to be true or not. But when it says assert it to be positive, they wanted us to make the assertion there. I was thinking more of the value of x than using the assert keyword.
The online platform is super important to us, and that's exactly why we have Rewind. What would you lose? And if your website was down, how many orders would you be losing as well?
Okay. And let me see, opening files. That can come in handy. You can use Python to read and write the contents of files. Text files are the easiest to manipulate. Before a file can be edited, it must be opened using the open function. Okay, and you can see here in the example, let me see, my file, and then this is the assignment operator. We use the open function, and then we pass into the open function the name of the file that we're going to be opening. In this case, file name.txt, and don't forget the parentheses and the quotes there. You might be able to use single quotes. They use double quotes in this example though. The argument of the open function is a path to the file. If the file is in the current working directory of the program, you can specify only its name. If it's a path, then you would have the names of the folders, and there may be several folders within folders, and they would be divided by the slash symbol. Which function is used to access files? I like they didn't use the word open. It's kind of a giveaway, so use a synonym, but the function used to open files or to access files is open. You can specify the mode used to open a file by applying a second argument to the open function. Open function has to take at least one argument, that is the path to the file and the file name, or the file name if it's in the working directory. At least one argument. By applying the second argument, you can specify a mode. And R means to open in read mode, which is the default. W means write mode for rewriting the contents of the file. A is append mode for adding new content to the end of the file. Adding B to a mode opens it in binary mode, which is used for non-text files such as image and sound files. For example, write mode open file name, comma, W, and apparently it's important that you put that in quotes there. Read mode open file name, R for read. And for some reason we've got open again. Why? Oh, you know why? This is why. That's the default. These are two different ways to do the same thing. Read is the default function, default mode. So if you don't specify anything, it's automatically read. And then binary write, open, file name, write, or W for write, and then if you use the B tag, then you're going to put it right next to the W. Or if you're reading or rewriting, reading or appending also. You can use the plus sign with each of the modes above to give them extra access to files. For example, R plus opens a file for both reading and writing. And here we're being asked to drag and drop from the options below to open a file called test.bin in binary read mode. So we've got test.bin, binary read, let me see, read binary. But I think you could also just put the B in there as well, because read mode is the default. So let's see if that works. RB will definitely work, but I think just the B will work as well. It does not like that. So let's try RB instead. Test bin. Okay. Seems like they could have coded it to accept just the B, if that works, or it may be that you have to specify R before you put the B on there. Once a file has been opened and used, you should close it. This is done with the close method of the file object. So open, we call the open function, specify the file name and or path. We can use write. If we're writing, we have to use that. If we're just reading, we may or may not use the R. And then we do stuff to the file. Notice our octothorpe here. So this is just kind of an explanation. We do stuff with the file. Now we use the dot operator to use the close method on the file object. So it's file dot close rather than using the using like a close function. So we use the close method on the file object there. We will read write content to files in upcoming lessons. How would you close a file stored in a variable text file? We would do, text file is the name of the file, text file dot close. Notice here, this is like the close function and passing in the name of the text file. These are not correct. We use the file object and then dot operator to call the close method on that object. Okay, and reading files. Looks like we'll be doing a lot of stuff with files. Reading files, writing files. The contents of a file that has been opened in text mode can be read using the read method. Gotta love English. Read and read are spelled exactly the same. Alright, so file, and we're going to assign a file, open file name dot text, and then we're going to open it as a read. cont equals file dot read, print, and then cont, which I'm going to assume that this is an abbreviation for contents, and then file dot close. This will print all the contents of the file name dot text. So what we're doing is we're making a file and we're going to assign to it basically this file. This is the file name dot text. So now we can work with this file object, which is basically going to be whatever this file was. So we call the open function specifying the file name. Now we can work with this object, the file object. We're going to assign to cont for contents the file object, but we're going to call the read method on it. And so that's basically going to dump all the contents of the file, which is the file name dot text, into this variable or this object cont, and then we're going to print cont, and and then we're done. That's basically all that we needed to do. But before we leave the program, we're going to go ahead, invoke that file object, and call the close method on it. So we're closing it out. So when you're doing, especially if you're doing self-paced study, if you're doing self-learning, or learning via electronic means that can be paused and started and rewound and things like that, you should go through examples like this and make sure you understand each line of code and what it's doing. And if you have to rewind or if you have to pause, that's fine. It's absolutely fine. Just make sure you get it before you move on. This actually reminds me of a practice called rubber duck debugging. In rubber duck debugging, a computer programmer has a little rubber duck sitting on his desk, and when he has trouble figuring out why a program is not doing what it's supposed to, trying to find the bug, trying to figure out what's wrong, he talks to the rubber duck. He reads through the line of code, looks through every line of code, and explains what each line of code is supposed to do to the rubber duck. Well, obviously rubber ducks don't help you debug programs, but cognitively, the process of explaining what each line of code does to someone, even if they're an inanimate waterfowl, is going to probably jog something in your memory and your awareness, and you'll realize where the error is when you explain it. So, and when I went through 3-month full stack coding boot camp, our instructors actually made a gift of a rubber duck to each one of the students. I still have it. So rearrange the code to open a file, read its contents, print them, and then close the file. So let me see, open a file. Here we go. File, open, tests, and we're going to print the contents. Print contents. That's actually not next, because we have to define here the variable or the object cont as something. We're going to invoke that file object we just created and then call the read method on it, and then we print cont. The program will run fine, but you really don't want to leave files around open. Just as in a physical office, probably not a good idea to have important documents just lying in full view, so we're going to close that. Invoke again the file object and then call dot close method on that file. Reading files. To read only a certain amount of a file, you can provide a number as an argument to the read function. This determines the number of bytes that should be read. You can make more calls to read on the same file object to read more of the file byte by byte. With no argument, read returns the rest of the file. So let's say we've got our file open to read, print file read 16. That will be the first 16 bytes of the file. Print, and it will display it to the screen, obviously. Print file.read4 says to read more of the file. We've already called read on the file, so I'm thinking this next one is going to read the next 4 bytes, so bytes 17 to 20, and then this will read 21 to 24. This one has no parameter, no argument specified, so it would read the rest of the file all the way to the end of the file, and then we close the file. Just like passing no arguments, negative values will return the entire contents. So actually negative does not throw an error, it returns the entire file, or the rest of the file. How many characters would be in each line printed by this code if one character is 1 byte? So we're going to open our file. For I in range 21, print file dot read 4. So how many characters? Let me see. So range 21, but each one is going to print 4. So I'm thinking this is going to print 84, because it's going to be 4. Oops, that's not right. I'm only allowed to put one character there. How many characters? Oh, in each line. Okay, so this, as it iterates through, it's going to be 4 characters, and then there's going to be 21 lines. So it's actually, I believe, going to be 4 characters. Yeah. I totally would have said 84. Which is, as I visited this earlier to revisit what I stated in an earlier video, make sure you read the question carefully, because a lot of times you'll come up with the right answer to the wrong question. Your reasoning is solid, your understanding of programming principles, you're paying attention to the quantities and the numbers, your math is right, but you answered the wrong question. You answered what you thought they asked, not what they actually asked. So, be sure you pay attention to that. Now, the risk of me giving the wrong answer here is pretty low. I just, fix it and move on. But if you're doing, the more important the task that you're doing, the more vital it is that you make sure your expectations, the parameters, make sure you're solving the right problem, the one that's asked, not the one that you thought was asked. After all content in a file have been read, any attempts to read further from that file will return an empty string, because you're trying to read from the end of the line. And that's interesting, an empty string. It doesn't throw an error. It doesn't have an exception. It just returns an empty string. I could see some problems there, because if you get empty strings, does it mean that you're getting empty strings because there is a gap, a lacuna in the file where there's no data, or does it mean that you're at the end, you're past the end of the file and there's no data? It's an interesting possibility there. So here we go. Open the file name, text. We're going to read it. File read, print rereading, print file read, print finished, and then we close the file. Okay, just like passing no arguments and negative values, return the entire contents. Fill in the blanks to open a file, read its content, and print its length. Print its length. So let me see, file, open, and then we're going to read here, print length string. Oh, okay, that's interesting. So we've got this variable here, and by invoking the file object and calling the read method on it, we're making this into a string, and here we just print the length of that string, the length function, and we're passing in the string that we established here, and then we close the file. Now we're learning. And to retrieve each line in a file, you can use the readLines method to return return a list in which each element is a line in the file. So we open the file, print file, and instead of read lines, and then we close. And the result we get, okay, so what we get here is a list. See the brackets? That's indicating that it's a list. And then here you can see the commas that are separating the individual items in the list. Also, individual items are enclosed with quotes. You'll notice the last bit in each line is the escape in, the new line character, which is going to cause the file to have to break into the lines there. Except the last one, no new line there. You can also use a for loop to iterate through the lines in the file. For line, and this can be anything, it doesn't have to be line as long as it matches here. For line in file, don't forget your colon, and then we're going to print, and then Here it's line. You can use anything you need as long as it matches up here. And then we close the file. And the result will be line 1 text, line 2 text, line 3 text. In the output, the lines are separated by blank lines as the print function automatically adds a new line at the end of its output. And that's why we have that. Why aren't these squashed together? When it's printing, for each loop through here, it goes to a new line, which puts the output right here. Except that the file also has a new line escape in, is the new line character. So the for loop prints this out, goes to a new line, but then, well, actually it prints this out, and then the file sends it to the next line, and then the for loop puts another new line in there, which is why we have those spaces there. I kind of wondered about that, but I didn't think that I think it was important enough to bring up, but then the course pointed that out. If the file test.txt is, let me see, or has 7 lines of content, what will the following expression return? Then open test.txt.readlines. Okay. When you see stuff like this, it's usually best to work from the inside out. So we've got read lines, okay? Well, what do you read? Read lines. Read lines of what? Test text. That's the name of the file. Here we're opening it, and there is length. So that's what we're going to have. It's going to be counting read lines. I think that'll work. Length opened. Is it going to be 7? Yeah, it's kind of, it seems like it was a trap. 7 seems so obvious that I was wondering if they were trying to use some misdirection there, but maybe not. I guess maybe overthinking it. Alright, we're in a little bit long. We're like at 52 minutes. So we're going to finish up with writing files, working with files, and we've got the Module 4 quiz coming up for the next episode. As always, thanks so much for joining us. And as always, like, subscribe, recommend the channel. Any comments, questions, critiques, or requests are always welcome in the comments. Thanks so much for joining us here at Cajun Coding, and I'll see you all next time. Bye-bye.